RAT stands for rocking and thinking. My professional career spans about 42 years now. Half of it was spent working for the Department of Defense. A lot of this had to do with photonics. How do we generate and relay photons into the eyes? We have a remarkable visual system. We have 3 pigments in the receptors of our eye, red, green, and blue. Discovered with shrimp really have like 18 different receptors. Now let's look at the honeybee. Has maybe 4 receptors. But one of those receptors is up into the UV. We wanted to take advantage of everything we could learn about how animals perceive light. And so that led us to this idea, what we want are devices that have eyes, different eyes that look into different spectra. Where the Cyclops would have, in essence, 32 different colors that it looked at. When we drive it up to different steps, we have 25 times 32 eyes to see. And then on the receiving side, if we had a way to look at different spectral returns, then what we would have is maybe 3,000, 4,000 eyes that would help us discriminate this fingerprint, nature's fingerprint. So we're actually doing an improvement on Mother Nature. Can we see the technology in action? There are really sort of 3 considerations about technology.
It's extremely small. The system is very physically robust. It can also be very high speed.
Up to 1,000 times a second. We feel that we can discriminate something that's in a production line. If you're only using human vision, then it is easy to counterfeit. We go beyond the visual range, into the infrared, into the ultraviolet, and we can see things that are built into the material that you would not be able to recognize with visible light. Now, how much does it cost? We're now talking about a technology, instead of being maybe thousands to tens of thousands of dollars, of being hundreds of dollars, and still having the same performance. We believe that there are so many applications for the technology that go beyond the authentication. As a matter of fact, many of the exciting ones have to do with medicine and healthcare and terrorism, and with environment, with agriculture. Yes, an invisible barcode would be easy to do.
As a very small gray dot on an article of clothing or on a box of software on a DVD, for instance, which can then encode information such as the date of manufacture of the software, where it was manufactured, the license number, really any information you'd like to encode.
And that's where our technology can help.